Alright, Matrix, this is the next part of that worksheet that I put up. Question 7 and question 8, more proving identities with a little bit extra on top of it. So for number 7.1, it says, prove that sine 45 plus x sine 45 minus x is going to equal a half cos 2x, and hence, that word hence is key here, means you need to use what they just asked you to do in order to determine the value of sine 75, sine 15 without a calculator. Alright, so we're going to first do the first prove part, and then we'll work on to the hence. So we're going to start with the left hand side, because that is the little bit more complicated side. There's a lot more to do. So we can expand that sine 45 plus x, and we're going to expand it to become sine 45 cos x plus cos 45 sine x. Again, remember, we keep the same sign for sine as was in the bracket. Then we are multiplying it to sine 45 cos x minus cos 45 sine x. Please be careful, you are not adding here, you are multiplying. So when you have two binomials being multiplied, we're going to have to FOIL. Let's get rid of that arrow. Alright, so we are going to FOIL this now, and we're going to see we have exactly the same thing in each bracket, but one's got a plus, one's got a minus. That's a difference of two squares, dots. So we're going to go sine 45 across, and that's going to become then sine 45 squared cos squared x, and then when we multiply to the next term, it's going to become negative sine 45 cos 45 sine x cos x, but then we're going to take that same one and add it. So we had negative, and now we're going to add the exact same term. So that dots goes away. The middle term goes away in dots, so you don't even have to worry about it. You just then have to worry about your first term, the green one, and your last term, the other green one. So that's going to become then a positive times negative cos squared 45 sine squared x. Alright, so now in the next step, we're going to put in the special angles for sine and cos 45. Now, because 45 and 45 make 90, you only have to work out it once. Sine and cos will have the same value for 45 and 45. I've done it in such a way so that you can see that when we're putting in the special angle, the whole thing was sine 45 squared, so it's the special angle squared. And so, same thing there. So we end up simplifying it, and let's see what we end up getting. Alright, so we end up getting 2 over 4 when we square root 2 over 2, which is a half. So we get half cos squared x, minus a half sine squared x. So I can take out a half as a common factor, and I'm left with cos squared x minus sine squared x, which is your double angle for cos, so it becomes a half cos 2x, which is your right-hand side. And that's what we have. So now we're working with the idea of hence, meaning use what they just asked you to do in order to work out the next piece. Alright, so the next piece says we've got to work out what sine 75, sine 15 is. Now, I'm going to link it to the previous question. We can say that this is sine 45 plus 30 times by sine 45 minus 30. So all I've done is I've replaced the 75 with something equivalent, the 15 with something equivalent. Why have I picked 45 and 45? Because that's what we were working with originally. We were originally working with here in the original question. If we have a look there, sine 45 plus something, sine 45 minus something. Now in this case we can use the 45 plus 30, 45 minus 30. So effectively they're telling us in this question that we can make our x equal to 30 degrees. Alright, so then using the shortcut now, because that's what they wanted us to do, we know that this 45 plus something, 45 minus something is equal to a half cos 2x, so it's a half cos 2 times 30, which is a half cos 60. Cos 60 is a special angle of a half, so that value is a quarter without using a calculator. Alright, a similar sort of idea for 7.2. We need to realize that we can build up, so without using a calculator, special angles that will get us to the 105. So in this case, I'm going to say it's going to be sine 45 plus 60 plus cos 45 plus 60. Just make sure we're stating we're working on the left-hand side here. Alright, so then we can expand this into our compound angles, and then we can use all our special angles to substitute in. Alright, so what I've done is I've substituted in for the sine 45 cos 60, and then you can see I've bubbled in different colors the answer to each of the brackets. So remember, when you're multiplying fractions, it's top by top, bottom by bottom. So root 2 times 1 is just root 2, 2 times 2 is 4, and then the same thing when we're working with root 2 times root 3. Now remember, you multiply what's underneath the square root, and then 2 times 2 is 4. So then we end up with two like terms here. So when we're working with the root 6 minus root 6 over 4, that's going to cancel out. So then all we're going to be left with is root 2 over 4 plus root 2 over 4, which means then we are going to have 2 root 2's all over 4, which then simplifies to 1 root 2 over 2. Now, if you know your special angles, this can also be seen as 1 over root 2 for those who know a different method for finding your special angles. Both of these are equivalent to cos 45 degrees, which is your right-hand side. So this is one where you have to work backwards into your special angles. So it's a little bit more challenging, but even if you can just get to this point, then even if you can't finish it off, at least you'll get the marks up to that point. You'll just lose one final mark there. Alright, moving on to the identities for 8.1. For the most part, except once we get to 8.10, we are working just with left-hand side, right-hand side. So for question number 1, you have two options on where you want to start. The left-hand side doesn't really have much. Once you expand, you're not going to be able to do too much, so we're going to rather prefer to work with the right-hand side first. But if you feel you do want to work with the left-hand side, in the memo that I've posted on the Google Classroom, it does have the left-hand side up first. I just prefer the right-hand side. It also helps us practice the fact that we have a binomial being squared, so we need to FOIL. So let's practice foiling out these ones within the trig, because as we know, that's a little bit of a rusty section for you. Okay, so sine times sine is sine squared x. Sine times negative cos is negative sine x cos x. And then we're going to minus another one. I'm just going to keep it in the same order. And then negative times negative is positive cos squared x. So then I'm just going to group certain bits. I'm going to group the sine squared plus this cos squared over here. And then I'm going to work with this is the like term of negative 2 sine x cos x. Then from your grade 11 identities, sine x plus cos x is equal to 1. And from your grade 12 identities, that is your sine double angle. And then that's going to get us our left-hand side. Alright, so you could have expanded that out, 1 minus sine 2x. and then worked backwards by then working with, that is sine squared x plus cos squared x. But then you're going to have to recognize that that's a trinomial. Move the cos there and then factorize it into the two brackets that you had. And then realize that that is the same as the left-hand side, sine x minus cos x all squared. Sorry, the right-hand side. So it's doable, but I think the right-hand side was the easier side to work with. All right, for 8.2, I've made a note here. It's only for 2 marks, so it's something very quick. And so I'm going to start with my left-hand side, and I recognize at the top 2 sine x cos x is my sine double angle, and at the bottom cos squared minus sine squared is my cos double angle. And when I have the same angle top and bottom, sine over cos, it makes tan 2x, which is my right-hand side. So all you're getting a mark for really is recognizing those two. So 2 marks, and that's it. All right, but for 8.3, it's for 5 marks. So we need to do a little bit more work. So we're going to start on the left-hand side, because that is clearly the more busier side. And then we're going to work through our double angles here. So at the top, you don't really have a choice of double angles, because the sine 2x is 2 sine x cos x. That's the only option you have for that. But at the bottom, we have the cos double angle, and the cos double angle is one that has 3 options. So you could replace it with cos squared x minus sine squared x, or 2 cos squared x minus 1, or 1 minus 2 sine squared x. Whatever you're replacing with, please put it in a bracket, because there is that subtraction there which will need to be distributed as a negative. So when we're working with this one, you've got to look at the right-hand side. See what's happening there. We need 1 plus 2 sine x. There's no causes there. At the moment, we've already got a 1 plus sine x at the bottom. So let's try and bring in a cos. So I'm going to pick the one that only has sines in it and hope for the best. So let's see how it works. So we're going to, at the top, see that we have a common sine x. So I'm going to have 1 plus 2 cos x. And that's already kind of looking like what I need at the top of the right-hand side. And then I've just got to do some distribution here. So I'm going to distribute the negative in. And then we're going to have to simplify. So when we're working with the simplifying, keep the top as is. And then let's see what the simplifying at the bottom is going to be. It's going to be 2 sine squared x plus sine x. 1 minus 1 goes away. So we're actually left again with another factorizing question. Alright, so then we have this situation where I factorize another sine x out. My sine x can cancel each other, and I'm left with 1 plus 2 cos x over 2 sine x plus 1. But because everything's positive at the bottom, if it was negative, you'd have to do a switch around, take out a negative. But because they're all positive, you can just rearrange it like you need, and that is going to be our right-hand side. Alright, so now for 8.4, it's also only for 2 marks, but it is quite tricky to recognize something happening with that 6x. We've only got 3 x's, so I'm going to keep my left-hand side as my focus, so cos squared 3x, and then I'm going to change 6x to 2 times 3x, a double angle. So because I need a sine squared 3x on the other side, and so I'm going to pick the one that has then cos squared x minus sine squared, sorry, not x, 3x. You match whatever's in your bracket as your angle. So that's going to be cos squared minus the cos squared. So the cos squared 3x's are going to go, and we're going to be left with negative times positive is positive sine squared 3x, which is our right-hand side. So you have to recognize, unfortunately, the 6x situation, otherwise you won't be able to carry on with the question. Alright, so for question 8.5, it's for 6 marks, which generally means there's going to be stuff to do on both sides. Not always, but here I can see that the left-hand side and the right-hand side has lots of things for us to do. So choose whichever one you want to start with. I'm going to start with the left-hand side because that's the kind of the traditional thing that we work with. Alright, so now when we're working with a fraction added or subtracted to a fraction, we need to think about an LCD. So our LCD in this case is going to be each of the denominators. 1 plus cos x times 1 minus cos x. So then you're going to multiply top and bottom by this. So we're going to get 1 minus cos x on that side, and then same thing there but with the opposite sign. Right, so at the top we're just going to get 2 because 1 plus 1, and then the cos's cancel each other out. And at the bottom we're going to have to do some foiling. But remember, because we're working with 1 is a plus, 1 is a minus of the same thing, the middle term goes away. So you actually only have to focus on 1 times 1 is 1. And then positive cos times negative cos is negative cos squared x. Alright, now from looking at our right hand side, we don't need cos's at the bottom, we need a sine at the bottom. So 1 minus cos squared x comes from your grade 11 identity, where it's cos squared x plus sine squared x equals 1. Careful, it's different to your grade 12 double angle that would have a minus between. So if I wanted to get sine squared x by itself, I take the cos over, and it becomes 1 minus cos squared x. So where I see a 1 minus cos squared x in my question here, I can then say it's sine squared x. Right, so I've already got something happening on the left-hand side where I've got rid of the cos's, because on the left-hand side, the right-hand side, I have no cos's at the bottom, so now I have no cos's at the bottom on the left-hand side. Right, so my right-hand side, it's quite a nice one here because you only have one double angle to work with. So we're working with sine x cos x with a 2 in front of it. Tan is equal to sine x over cos x, and then that is all being divided by sine to the power of 4x. So now I'm able to cancel out the cos and the cos, and I'm left with 2 sine squared x over sine to the power of 4x. So because that sine times sine multiplies there. So now, imagine you had 2y squared over y to the 4. You'd be able to cancel out the y squared with then sum of the bottom. So we are left with 2 over y squared. So the same thing here. We've got squared over the power of 4, so we're going to be left with 2 over sine squared x, which is now our new left-hand side that we built up there. And then you can then conclude that your left-hand side equals your right-hand side. Alright, for 8.6, also for 5 marks, a lot of marks, I'm going to start with my left-hand side. I've got a double angle at the bottom that I'm going to work with first, and then we'll decide what we're going to use as our double angle for the cos in the numerator. Alright, so I've just changed the sine 2x to its double angle expansion. So now at the top, I could work with any of the 3 cos 2x's. I'm not 100% sure where I want to go with this, so I'm going to work with maybe the right-hand side at the same time over here. Let's see where we want to go with this idea. Okay, so I'm just banking my left-hand side for a little bit, and I'm working with my right-hand side. I've changed tan to sine over cos, and then now that's saying it's 1 divided by sine over cos, which means I can say 1 times cos over sine if I tip in times, and then 1 over sine x there still. So now I've got cos x over sine x minus 1 over sine x. They have the same denominator, so I can join it to cos x minus 1 all over sine x. So now if we go back to our left-hand side, let's see, I've got at the moment a cos 2x minus a cos x. in the numerator, and in my right hand side numerator I have coses. So I'm going to go back now to my left hand side, and I'm going to rather use the double angle that only has coses. I don't want to bring any more sines in. Let's see how this goes. So when I have 2 cos squared x minus 1, that replaces the cos 2x, then minus cos x. So let's look at the denominator here now as well. Can you see that I have a common sine x? So I have 2 cos x plus 1. And look at my right hand side that I've built. My denominator here is sine x. I've got the sine x on my left hand side, so which means I should be able to get rid of that bracket at the bottom. So if we have a look now, this 2 cos squared x minus cos x minus 1, I've ordered it like that so that it's a trinomial quadratic. 2 something squared minus something minus 1, we have the normal quadratic situation, which means I need to factorize it into 2 brackets. But the handy thing is the 2 brackets have already been done for you. I know I need to get rid of that bracket at the bottom, so I will be able to cancel it out. But I know in my final answer I must have that cos x minus 1. So it's already been factorized for me. I just need to use the information. So my trinomial will factorize into 2 cos x plus 1 and cos x minus 1, and then our 2 brackets top and bottom will cancel, and we'll be left with cos x minus 1 over sine x. So therefore my left hand side matches my right hand side. So it just shows you don't need to finish a full side. You are more than welcome to work with them next to each other. Don't mix them, but you can even build yourself a little wall there, so you can't bring things from the right to the left, but you can use your right to help you think ahead in your left, or vice versa. Alright, so now for 8.7, we're definitely going to be starting on the left hand side. The right hand side doesn't have anything else to work with, so on my left hand side I'm keeping my denominator as is. I'm just going to put in a bracket, just so that when if we get a bracket at the top we can cancel it out. It's easier to see. At the top I have coses in common, so if I take out a cos squared x, I'll be left with a cos squared x plus a sine squared x. So then in the brackets here, that is equal to 1. So I'm going to have that as 1 minus sine x, and then I've got a cos squared x. Alright, so effectively I've got a cos squared x over 1 minus sine squared x. But cos squared can become 1 minus sine squared x all over 1 minus sine x. The only reason I'm doing that is because on my right hand side I don't have any coses, and so I need to get rid of the coses on the left hand side. So then at the top now, that is a dots. It's 1 minus sine x, 1 plus sine x, because they're both perfect squares. All over 1 minus sine x, lost my brackets there. Those can cancel, and I'm left with sine x, which is my right hand side. So unfortunately for most, the only trig that's involved here is to change the cos squared plus sine squared into the 1, and the cos squared into the 1 minus sine squared x. The rest is all algebra. Alright, the second last identity that we're going to prove, again we're going to work with our left hand side, because our right hand side is only equal to 2. Okay, I'm leaving my double angle alone for now because I don't quite know which one I want to change to yet. So I'm working with my tan squared x, which is sine squared over cos squared. So again, leave the double angle alone, and here I've got 1 plus cos squared x over sine squared x when I tip and times. And then here in this bracket I'm going to work with an LCD. Alright, so then I've got my LCD sorted out, and my top of my fraction there, my numerator. Sine squared plus cos squared is 1 all over sine squared x. And so then I'm going to decide now which double angle I want to change to. So in this case, if I need the answer of 2 on the right hand side, I need to be able to cancel out that sine squared x in the denominator. There's no sine squared x or denominator at all on the right hand side. So I'm going to choose to get rid of the sine squared x by using the double angle that has the sine in it. Alright, so this is inside my bracket here. My 1 is going to be 1 plus 1, 1 minus 1 over there, and then I'm going to be adding 2 sine squared x, and still all being multiplied to this fraction over here. So my 1's cancel out, I'm left with 2 sine squared x times by 1 over sine squared x. My sine squared x's can cancel, and I'm left with my right hand side, my 2. Alright, so your left hand side, right hand side for 8.9. I'm going to go with my left hand side here simply because there's things I can do. I can work with the double angles. Even if it doesn't get me anywhere, then I can flip to the right hand side. So again, I'm not sure which cos double angle I want to change to, so let's just leave it. But for my sine double angle, I'm going to have it as 2 sine x cos x, and then plus this 2. So cos 2x plus, that's going to become 4 sine x cos x plus a 2. Alright. Alright, so because I'm not quite sure where I want to go with this left-hand side, I'm going to be moving to the right-hand side. I have foiled the right-hand side, and I have gotten down to 3 cos squared x plus 4 sine x cos x, which I already have. I already have that on this side. So I'm already there, and then plus a sine squared x, and then I have 3 cos squared x's. Alright, so we need to bring in a sine squared, and we need to have a cos squared. So we can work with maybe changing our cos double angle to cos squared x minus sine squared x, which means at least we have a cos squared involved. Alright, and then I'm going to keep the 4 sine x cos x because that's already there, and then I'm going to do something different here. This 2 is actually 2 times 1. Now, in trig, we know that 1 is sine squared x plus cos squared x. So, I'm just filling in all the rest. Alright, so then I've just kept the beginning bit as is. Now I'm going to distribute this 2 in. I'm going to have 2 sine squared x's plus 2 cos squared x's. So my like terms, I end up with 3 cos squared x's. Negative sine squared plus 2 is going to get me the positive 1 sine squared x. And then my middle term. And that gets me to my right hand side that I've built. So therefore, left hand side equals right hand side. On the memo that I've posted on the Google Classroom page, they've only used the left hand side. So you can see an alternative, but that requires you to factorize the trinomial with coses and sines, which can be sometimes a bit challenging. So you can use left and right hand side here. Alright, and then for 8.10, I'm going to skip that one for now because it involves the general solution information, which I'm going to post a video about general solution and then work on question 9 onwards from this worksheet. But you need to kind of have a recap of general solution first, and then you can come back to the identities not defined for 8.10, and then hopefully understand the memo that is attached with this worksheet. So when you're working with identities undefined, you've got to give a general solution. Alright, so I will be doing the general solution video next, a recap of grade 11 going into grade 12 general solution, and then be able to answer the questions after that.